Guys, good morning all. And I requested you to go on mute everyone. If you have any concerns and queries on the related topics, we will address at the end of the sessions. You can ping me on the chat window so that I can see who are having the questions. So we starting this series of sessions for I want to help the people. That's it. This is not any institute promotion or anything. We are from DTaiLabs. I just wanted to understand there is a gap between the academic to the industry. I'm here to bridge the gap between the industry to the academic. That was one of the main reason we started this series of lessons on particularly computer vision. I'm not going to touch up any machine learning algorithm, and we are going to see some of good applications for deep learning and also NLP. Okay, this is completely free. Nobody is gonna question you and nobody is gonna charge you. That's it. Let's move on. Like I hope you most of the people have seen my LinkedIn profile, right? So I don't need to much explain about me. Okay, just move on. Hope I'm audible to everyone, right? If I'm audible, type one. Everyone, I'm audible, right? Okay, good. See, I need your participation, sir. I need everyone's participation here, so it will make the more interesting of learning. Okay, if I'm audible, let's move on. Right, computer vision, vision. Can I call this computer vision as a mission vision? Because what's happening in the computer vision system is able to read from the data instead of humans. That was the reason we are calling this as a mission vision. Mission vision. Or we can also call this as a computer vision. Many of you know the neural network concept. Here we are going to demystify in a very detailed manner. Like in neural networks, we have three kinds of. One is ANN, one is R deep neural networks, or CNNs, RNN. Right. ANN is for your structured data, and CNN is for your completely with image. And we are going to talk about CNN extensively. I don't think so. We may talk RNNs for this computer vision for deep learning, but more majorly focus into the different architectures in CNN. Trust me, we are not gonna do only VGG 16. Okay, this is not our cup of these workshops. We are gonna see the inception. We are gonna see ResNet. We are gonna see mask RCNNs. We are gonna see all kinds of big architectures, and it impacts to the computer vision community, right? And don't think that it's going to be like a pre-trained models and I will show you that I will execute. No, it's going to be like extensive end-to-end deep learning course which you can Imagine it's gonna be like different story. Right. Now we will see. In a computer, in like we are talking about convolutional neural networks. These have two parts. One is convolutional part, and another one is neural DNN. This is what the two parts. Convolutionals having different stages. What are the stages? Convolutional and padding, strides, max pooling, flattening. And fully connected layers. Am I making sense? Is this till this point understood or not understood? If you are understood, type 1. Everyone participation is important here. Meenakshi,
Hello, Suresh. Actually, I've connected from mobile, so
oh, are you able to follow, right?
yes, I'm able to follow. Yes,
It's clear, right?
yeah, clear.
Yeah.
Yeah,
Okay, thank
sure.
you. Okay. Convolutional, we have, as I said, two concepts. One is front end and other one is back end. Back end being used by this neural networks, DNN, which is used to classify your image, classify the activity. And whereas front end, it tries to understand the understand the features from a data. This will be passed to the backend of a sequence of feed forward propagation. Okay. The front end, what is happening? Let us say I have a image. I'm bad at drawing and don't complain. So we try to understand features by applying the series of operations. Right. So it has given to the back end classify or perform a task. These are the major steps we have in the convolutional process. whereas a front end, and we'll have the back end also. Now, Prasad, it could be like a similar last session, but it's gonna be like a different way. Now, we will go one by one. We will go by one step. Okay. We say what is a convolutional? Convolutional is a process of extracting the features from an image. So we do right when we do convolutional operation, image gets shrinkage. Example, your 6 by 6 is convolved with into 3 by 3. Your convolutional will become how much? Any idea? It's like 4 by 4. 6 by 6 image, 3 by 3. It is being convolved to extract features. So it is becoming 4 by 4. How this? This is what n by n, f by f. So my formula will be n minus f plus 1 and also n minus f plus 1. 6 minus 3 plus 1. 6 minus 3 plus 1. 4 by 4. I am getting the 4 by 4 matrix. Here, in the process of convolutional, we will go to the slides as a later point of time. We will try to understand. In the process of information extraction, my image getting shrinkage to next layer, next layers. Right. Imagine if you have bigger network. Finally, my output of this operations, this sequence operations makes image to very small where we cannot perform or we cannot our backend cannot perform any activity to it, right? So the shrinkage of data is the issue for computer vision. Any doubt here? If you are anybody having the doubt, you can raise out the your concern here. Okay, Srinivas asking N minus one. Okay. Okay. Let's go on mute, everyone. Here we have using the filters. Here for a convolutionals, to extract the features, we use concept called kernel or filter. The filters, the uses of the filters are used to extract the information from an image. So we will be using the filters like 3 by 3, 5 by 5, and 7 by 7, 9 by 9, and 11 by 11. Guys, please go on mute. Srinivas, now it's clear how it is n minus f plus 1. Srinivas. Okay. We will come to know. We'll come to know. We'll discuss. Okay. To extract the features from input, here is the some steps. Convolutional operations require this kind of information. One is filters, another one is stride, another one is padding. These are the major steps in the convolutional operations. Now we will see one by one. The filters is used to extract the information, and stride is a one more concept. How fast you are performing or reading the information, extracting the information. This padding comes into the picture when you do convolutional process operation, image get shrinks. To avoid this, we use we use padding option. The entire process, the padding is the one of the important, filters also one of the important, and stride. More filters, more data. You can read it from the image. So the basic fundamental. Stride is to how fast your system can scan. Padding to retain the originality of a image. There is a relationship between padding to the filters. Padding to the filters. We will see that. Guys, I could be able to hear some background noise. Go on mute. So we are talking about filters and we are talking about padding and we have a strides. So padding comes with the two flavors. One is valid, other one is same. Right. Valid in the sense when you do the convolutional 6 by 6 with the 3 by 3, you are getting the 4 by 4. This is valid because n minus f plus 1 into n minus f plus 1. So image is getting string. Now, based on the filters, I can choose if I wanted to have a same, my formula will be n plus 2p minus f plus 1 and n plus 2p minus f plus 1. Here, how many filters I have? Padding equal to f minus 1 by 2. Here is 3 by 3 filter. So 3 minus 1 by 2, 2 by 2. So 1. So what will happen now? 6 by 6 is convolved with 3 by 3. Now p equal to 1 I have and n equal to 6, f equal to 3. 6 plus 2 minus 1, sorry, 2 minus 3 plus 1. This gets cancelled. So I'll be retaining with 6 by 6. This is the importance of padding equal to same or padding equal to valid. Is this 2 points clear? Padding option. So this padding option resulting you there is a no damage to resulting the same image. So I am padding with 1. Line, see, I have a image of 3 by 3. What padding is doing? 1, 2, 3, 4. I am just adding a 0 padding here. So that when you do my convolutional operation, my entire image retains the same. So that was the reason we use the padding is, we will see, it's most important. This is the formula for the padding. Is this clear? Okay. Now we will go. What is the next step? We have done the padding. We need to see stride. Stride is how fast, right? This was the operations in the new slide. See, in convolutional, we discussed about stride, filters, and padding. After applying the convolutional, we apply other option called pooling layers. This is a other method of downsampling of important features. Important features from the feature map that is generated from convolutional operation. We have something called max pooling, average pooling, and something called global average pooling. This is the other operations in convolutional. Right. Now, then we have something called flattening. Flattening, right? Flattening, what is the flattening will do? The flattening will convert your two-dimensional array to one-dimensional array. It is given to the final layer and it can able to classify your activity. Classify the activity. This is what whole story behind convolutional neural networks. Is this clear, crisp and clear, or any doubt here? We are going to walk through the PPT one by one, don't worry about that, okay? Is this theoretically concepts are clear or not clear?
Suresh, will you explain about max pooling, average, and one more thing, what else? Will you explain in detail?
Yeah. See, max pooling is to taking the average from the given values, right? See, for a given matter, it's like so max pooling. We'll go and cover. Okay. Now you could see I have the image convolutional classical learning classify. The convolutional neural networks is a type of neural network can be viewed as a consisting of two parts, front end and back end. Back end is a deep neural network. The name convolutional neural network comes from the front end. We are doing the data here, extractions. DNN does the classifier learning. So CNN has performed a pre-processing of the image data form which is computationally practical for DNN. CNN front end does the feature learning. CNN what it does? It does the feature extracting from a image. CNN classifier. Once we get a larger image, the number of pixels DNN becomes computationally too expensive to the feasible. Presume that you have 1 MB image, which each pixel is represented by single byte. we have the values from 0 to, how your image will be storing 0 to 255 value. At 1 MB you will have the million pixels. 1 MB is having million pixels. So what we will do, we will, and let us assume that your input layer having 1024. The updated lens will be millions. This value will be computed with this many nodes. So it will be like highly computational. So what we are doing, we will be downsample the data. We are gonna do the process called 1024 to 1024. We are downsampling the image to 224 by 224. You will have the less parameters. This is what downsampling or resize is one of the key activities. We'll talk about convolutional layers. We discussed, right? We will go back again. The training of a real world image was to reach out a neural network till discover using the convolutional neural layers. To begin with, convolutional layer is the front end of a neural network which transforms this is what important, transform the images from a higher dimensional pixel image to subsequently lower dimensional features based image. So we are, when you are doing your convolutional operations, we are downsampling the data. Again, we are been extracting and we are applying the max pooling to downsample the data to extract the correct information, the useful information, not correct. The word is to be more precisely useful information. The subsequently lower dimensionality features can be inputted to the input vector to DNN. The convolutional front end is a front end between the image data and the deep neural networks. So feature detection. That's what we discussed, right? The convolutional is nothing but your feature detection. The convolutional layer performs this task of feature detections with image. If you have the filters, if you have a n by n matrix, I have a f by f, and so my output will be n minus 1 plus f. This formula might be, people will be know who has completed their course on the deep learning Andrew Ng. These formulas will be taught by him only in the world. Nobody will talk about this. This gives you some justification of why the image getting shrink in the forward layers. And what's important, the result of this convolutional, this is what very important. Write down this point, note down this point. A generated value that indicate how strongly the features are detected and located in the image. This is what your convolutional operation works. This was the beauty of your convolutional processing. And filters. We talked about filters. Filters are kernels. In a convolutional layers, one specify the size of the filters and number of filters also we can mention. Typically sizes are 3355 and 33 are most common. I'll tell you the reason why 33 is preferred. Because when you are using the padding, when you have odd values, now what will happen? My padding equal to my formula will be f minus 1 by 2. If I have 3 filters, 3 minus 1 by 2 equal to 2 by 2. It's gonna like 1 padding. Let us having image of 3 by 3. Okay. Now I can add Guys, someone is playing a video in a background. Can you please stop it? It's very disturbing. It's disturbing. Now I could able to add my zero padding here, so I could able to retain my original image. Imagine now, I'm going back to the real case. Let us say I have a even filter like 4 by 4. I am using it here. What will be the padding here? 4 minus 1 by 2. It's 3 by 2. It's 1.5. Where I cannot add 1.5 meaning of this or this or this. I cannot add anything of 1.5 values here. I cannot add any 1.5 here. So this will not make my model to learn the features perfectly. So that was the one of the major reason that convolutional having the filters of odd filters. Odd filters. I hope everybody clear on this odd filters. Why are we not using the even filters? The number of filters varies more, but typically multiples of 16, 32. You can use the filters. Like I have a 3 by 3 is my filter, so that I can have a 16 filters, 24 filters, so that I can read the data faster. Read the data more faster. More information. The output of the convolutional is nothing but your feature map. See, this is what we have taken the important ones like eyes, this legs, everything, and we'll be storing in a so called feature map. More filters, more data, bigger strides. Okay, now we are coming to the stride part. We are coming to the strides. Now let us say you want to climb, you are given a task to climb a stairs of 4 floors and pick each article placed on a staircase. This is what the task is given to you. What you do ideally, you start climbing and you pick every particle placed on each step, and you will get maximum values. This is what when you are climbing 2 steps at a go or 3 steps, even you collect information but comparatively less. So here stride I am mentioning to how fast I should collect. After this stride, this operation is a part of your convolutional only. Alright. Am I making sense? Stride. Anybody having doubt here? You can ask me. You can let me know your doubts. Any doubt? Clear. No, I was was waiting for any doubts for you from your side actually. Prasad garu, any doubts? If everybody understood, type 1 here so that I can understand that you are able to follow. I need everyone participation. Rajesh, Ravi, Satya.
It's clear, Suresh.
Okay. Satya, any doubt for you? By this time it should be clear. Okay. Okay. Now, okay. Here is the most important point. Pooling layers. Pooling layer is to, even though the even the each feature map is generated is the less than size of the image because we generated a multiple feature maps and total size has gone up. The next step is when you are using the multiple filters, like one filter will have the one value. If you have the 16 filters, you'll have the 16 values. So we need to next step is to reduce the total amount of the data while retaining the features are detected and corresponding to the spatial relationship between the detected features. This is what important on the pooling layer. We wanted to do pooling layer. Pooling layer is the step is referred to be pooling. The pooling is the same as the downsampling, whereby the feature map are resized to smaller dimension with important feature, the spatial relationship between the detected features. There should be a relationship between the features. Relationship between the features. In a pooling, we set the size of area of the pool. N by M matrix is also called the stride. The common practice we use 2 by 2 pool size with a stride of 2. Like I'll be having 2 by 2 and with a stride of 2. Let us have a 1, 1, 2, 3. I'll have a 4. Right? This pooling layer will be applied to 2 by 2 here. Then we take the maximum value from this 2 by 2 box and we will store it like the maximum value. This value is x. Then again stride of 2. So I'll be taking this maximum value. Here stride of 2, right? So I need to leave this x2 y2. This how my here instead of maximum value we can take the average value out of among these 4 values. The max pooling or we apply average pooling. See, now I am taking the 4 values. This 4 values, and we are stacking it. This is how your pooling layer works. And this is what very important phase of your neural network. The deep neural network takes the vectors as an input that has a one-dimensional array of the numbers. In case of the pooling maps, we have a two-dimensional matrix. So we need to transform into the single-dimensional vector, which can become an input to the deep neural network. This process is called flattening. I have a feature vector, right? 1, 2, 3. So I need to stack it one by one with a 2D. We are transforming one dimensional. Then we are giving it to the DNN to classify. This process is called 2D to 1D is called flattening. This is called flattening. Now you see the basic structure of your convolutional neural network. Now let us say, for like here we need to import TensorFlow.keras model. I have a sequential convolutional 2D for your convolutional operation, and you have a max pooling, and we have to flatten is for converting 2D to 1D, and max pooling is to extract the proper information, convolutional to take the features. So I hope I believe that your activation functions. Right, now let us see. Create a convolutional layer of 16 layers of 3x3 filter and a stride of a 2. What will happen? The stride means 2. It is what we wanted to read the data. We wanted to read the data up by two strides at a go. So we wanted to read this one, and we wanted to read this also. 2, right? 2 strides. So 3x3, right? This is what I have given 3 only. Sorry. I'll 1, 2, 3, 4. I'll read first 3, then stride of 2, so that I will leave these 2 elements. So next one I'll read this. That's how my striding will work. So if you are using this is called the channels. Input equal to 1 channel means it's a grayscale image. If it is in a 3 channel means it's in a RGB image. Now, max pooling. The output of the convolutional layers is passed through the rectified linear unit to activation function, which is then passed to max pooling layer. The size of the pooling region will be 2x2 and is specified as a pool size with a stride of 2 or the parameter of the strides. Here pool size and strides will mention. Then what is the next step we are doing? We are using the flatten to make your 2-dimensional to 1D. This is what whole operations will be done in your convolutional. See now, I am using the activation function is softmax is used for multi-class classification, and for a model, any neural network, define a model and compile a model, then fit a model. For machine learning, we have fit model, we don't have the compile method. Whereas in a neural networks, we need to compile it. Categorical cross entropy is one of the last function for your classification, and Adam is the optimizer, and accuracy for your accuracy for your performing your classifier. So this will be the outputs. We'll start with the input shapes. So max pooling layers, softmax, and this is what my output number. The model equal to inputs comma outputs. That's how we do. This VGG will come to the tomorrow.